In this problem, we need to use the rational zero theorem to find all potential rational zeros of this polynomial. We do not need to actually figure out which of these are the zeros. We just need to identify the list of potential candidates for the rational zeros. So this is a simple problem as long as you remember what to do. So let's say we have a rational zero c, which we can represent as p over q. It's a quotient of two integers. And here's the key idea. The numerator p will divide the free coefficient. The denominator q will divide the leading coefficient. And so this will give you all the possible choices for p and q. Let's figure out what they are. So what are the integral divisors of 8? And because division is always up to plus minus sign, we have plus minus 1 as possible choices, plus minus 2, plus minus 4, plus minus 8. Similarly, for q, what are the possible divisors of 2? Well, there are 1 and 2, but up to a sign, these are plus minus 1 and plus minus 2. All that remains now is to create all possible combinations, with the blue numbers being on top and the green numbers at the bottom. So let's write out all the possible rational zeros or roots in this case. First, if we use the denominator q equals to plus or minus 1, then of course the list of all the possible numerators gives us 1 list of all the possible roots. But now we can also use plus minus 2 for q. So let's write this out. If we use 1 plus minus 1 for p and plus minus 2 for q, then we get plus minus 1/2. Next, if we use plus minus 2 for p and plus minus 2 for q, then we'll get 2 over 2, which is 1. That's already accounted for. We already have plus minus 1. Next, plus minus 4 divided by plus minus 2 will give us plus minus 2. It's already been accounted for. And then plus minus 8 divided by plus minus 2 is plus minus 4. It's already part of our list. So this is the exhaustive list of potential rational zeros of this polynomial. This is our answer.